that mat to sit there at the proper heating level.
Yeah.
And that was apt. You really can't game on that.
Okay, guys, let's get started.
It's their fault.
Solenoid A is tightly wound, while solenoid B has windings that are evenly spaced with a gap equal to the diameter of the wire. The solenoids are otherwise identical. Determine the ratio of the energy stored per unit length of these solenoids when the same current flows through each. Okay, so
Energy is stored in the magnetic field, so set it up, set the
no,
current.
hang on a second. So here's a okay. So A, it's tightly wound. Okay, and I'm not going to draw any more of that stuff, so you know that's what goes on. Okay, so here is B, and they're identical except so B has each wire missing. Okay, so NA is the number of turns in this coil. What would NB be? 1/2 of NA. Oops. Right? Every other turn is missing, so you have 1/2 number of turns. Okay. Now, L is, you guys can check, is mu is N squared times A cross A times L. This is the L is the length and A is the area of cross section. Okay, so this A is different than this A, or we'll call those 1 and 2. Oh no, they're naming it solenoids. Okay. Whew. So there are two A's going on, and they have totally different meanings. Okay, and so if you're solving this at midnight, don't be swearing at me. All right. So NA is NA divided by L. NB is NB divided by L, which is 1/2 NA divided by L, which is NA. So the number of turns per unit length for coil B is 1/2 of the number of turns per unit length for coil A. Okay. So let's add a page. Okay, so LA is mu naught NA times area times L. LB is mu naught NB squared times A times L equal to mu naught square 1/2 NA times A times L. So LB is 1/4 times LA. Okay. So we've done all this to show you what we've shown you is, okay, so if here's a solenoid with tight windings, if every other turn is missing, the inductance of this is 1/4 the inductance of that. That's what we've shown you. Okay, so if every other wire is missing. The energy stored in an inductor, U is equal to 1/2 Li squared. Okay, so if the current is the same, so UA by UB equal to 1/2 LA I square divided by 1/2 LB I square. LA by LB equal to LA by 1/4 LB equal to 4. So if both the same current is passing through both the solenoids, solenoid A stores 4 times the energy in the magnetic field. Okay. So that's what that means.
Wouldn't that last LB be in LA?
I'm sorry?
Write it as 1/4 LB the last time? Shouldn't that be 1/4 LA?
Yeah. Okay. I say one thing, I'm thinking one thing, and I'm writing another thing. So there's 3 or 4 things going on at the same time. All right. Any other questions before we go on? So actually this diagram is messed up. I should have deleted it. Oh well.